Think you know some things about electricity and power consumption? Well, we might just be able to prove you wrong on a few things. This presentation was prepared by Steve Hudson, Vice President of Hardware Engineering here at Powermetrix in Knoxville, Tennessee. There's a few ideas floating around out there that may or may not be based on the evidence. Today, we're going to look into one of these. Is stranded wire better than solid wire in metering installations? Let's roll up our sleeves and see if it's true. Myth number 2. Is stranded wire better than solid wire in meter installations? Some of you out there have put some thought into this and have very strong opinions. Trust us, we've met a few of you. Before we get started though, we should probably decide how to decide. In order to truly compare the two against each other, our engineers put some thought into this and made a list of criteria. They decided to look at cost per foot, the cost at 500 feet, flexibility, resistance to corrosion, and electrical resistance per 100 feet. Let's take a look at the numbers. First, we find solid wire the winner when comparing cost per foot. Okay, it isn't by much, but when you start multiplying this by the number of installations in your utility, it could become a significant savings. And you can start to see this savings in the next parameter, cost at 500 feet, where the solid wire begins to pull ahead by a more comfortable margin. The issue of flexibility matters, depending on how the wire is used. More flexibility may be good if you need to wrap multiple loops of wire around a CT. Less flexibility is better if you need to form wires inside a meter cabinet. So we'll call this category a draw. Considering that most meter installations are subject to harsh weather conditions over long periods of time, resistance to corrosion is a significant factor to consider. Solid wire wins here because it has less surface area to corrode in the first place. But then we start splitting hairs, or should we say strands. It's true that stranded wire has less resistance per 100 feet, but it's by a tiny margin. There's not enough difference here to matter, so we'll call this category even. Okay, great. Solid wire sorta wins so far, right? Well, actually, we should look at what really matters when it comes to metering specifically. That could change a few things about how we think. And the first thing that we care about is the connection. When you're working with stranded wire, it's easy to miss a few strands here and there at the connection terminal. Be sure that set screws engage as much wire as possible. More surface area means less resistance, which is important in reducing burden for CT installations and reducing the potential for hotspots in high current applications. If we look at a typical transformer rated installation, you will see there are many connection points. If you add a little resistance at multiple connections, then we could be talking about a significant increase in the amount of resistance. This increase represents more burden. The more bad connections you have, the more burden you will have too. So here's where it gets interesting. Current transformers will only provide their stated accuracy up to its specified burden rating. Wait, let's define burden really quickly. It's the total impedance connected to the secondary side of the CT. Right, gotcha. And it includes the meter's current stator, test switch, connectors, and wire. So there are a lot of places things might go wrong here. Be sure to check meter installations for good solid connections at each of these places to ensure minimum resistance. We know that wire makes up the largest portion of the burden, which also has the most influence on the accuracy of the CT. Don't believe us? Well, we've got a chart. In this chart, you will notice we have 4 values of burden. As the burden value increases, the accuracy of the CT becomes less accurate. So if you were to use too small a gauge of wire, you could see overburden problems. For example, using 50 feet of 14 gauge wire has about 0.14 ohms of resistance, and this is more burden than is allowed for a 0.1 ohm burden class of transformer. Even using 12 gauge wire has about 0.09 ohms of resistance, and that's just about the whole burden allowed for this class of current transformer. So pretty much what it boils down to is that even if you had perfect connections at every connection point, using too small a wire would guarantee you get the worst performance possible from your CTs. Once again, it's important to reiterate that every one of your wire connections must be tight and free of oxidation to keep the burden as low as possible. Using the PowerMaster, we can actually measure this while the CT is under load. And by the way, this is the most accurate way to find out what the burden of a CT really is. Direct burden measurement can also be used to help troubleshoot problems in the field. Take an initial burden reading, tighten a connection, and measure burden again to see if the burden has been reduced. Continue through each connection until the proper burden level has been achieved. So, there it is. We know that wire makes up the largest amount of burden in a meter installation. We know that loose, worn, or oxidized connections can easily add ohms of burden. And we know that burden significantly decreases the performance of the site. So which one wins? Both solid and stranded wires give good performance, assuming care is taken when installing a meter site. So both win, but only when there are good solid connections. Thanks for watching. Let us know if you have a myth you'd like our engineers to bust. We love a good challenge, so send us an email or a comment. We'll jump right on it. And we always love hearing from you. If you have any questions, comments, or stories to share, let us know by commenting below or by starting a conversation on Facebook, LinkedIn, or Twitter. Sign up for our newsletter to receive updates when we post new training materials on our website at www.powermetrix.com.